Hi, hi everyone. Thank you very much for attending this workshop. My name is Ivan Grijalva. I'm a new assistant professor in precision pest management and data analytics at LSU. Here with my colleague Thanos, we are very happy to present this workshop. The topic of the workshop is about introduction cloud-based tools for labeling and training object detection models. Our learning objective for today is a very hands-on experience workshop. Is to build a detection model. Maybe you are familiar with this software that is open source. Also, you can pay the membership. It's called RoboFlow. RoboFlow is a very good program if you want to get into machine learning because you don't need to have the coding experience to build a machine learning model. It's a very useful tool for labeling, and the most important thing that is cloud-based and you can collaborate between any member. We will start to show you some imagery repositories that you can use for your own research, but we are providing the data set so you can download. You will have had experience in labeling images. We will train a machine learning model that can detect, in this case, dandelions and coccinellids, that is a natural enemy that you can find them in field crops. And the goal is to enhance your skills in machine learning and also give you a start point so you can build detection models in your own research. The first step is to download the dataset. Just let us know if you have the dataset and also unzip that folder. In that dataset, you will have two folders. One folder contains a lady beetle that was captured in wheat plots, and the other datasets are dandelions. So the goal for this workshop is to be able to detect those objects. That is very important for if you want to automate agriculture or if you want to build a ground robotic system that can detect coccinellids, or it can be a drone that can detect dandelions. The goal also for you today is to learn about how to use labeling. That is very useful in RoboFlow to be able to train a model with a platform and make detections in unseen images that the model didn't see it before. Right now, you can scan the QR barcode to see the different imagery repositories. I will go through RoboFlow, Universe. That is a very useful, okay, start without data. Let me see. Cool. Well, I don't think so. I have in this laptop internet, but okay. Let me do that. Okay. Yeah. The other you can just explore by yourself because I don't have internet connection in this laptop. But you can download the dataset. Just let us know if you have the dataset unzipped. You will have two folders there. One folder is with 50 images with coccinellids, and the other folder has 50 images with dandelions. And you can raise the hand if you have any questions so we know. Okay. We're good? Okay, the next step is that you need to create. Okay. Yeah, you can scan the QR barcode or just click in the link if you have access to the presentation. Yeah. Right. The next step is, I believe that you already create an account, but you can create an account in RoboFlow. You can scan the QR barcode, and also you can create a free public space that will be able to help you to label the images that you already download. Also, it will help you to train the model. Also, if you already signed for the account, I will go to the next slide so you can just sign in into your RoboFlow account. Okay. We are good in this step, everyone? Yeah, just the free version. Okay, I believe. Yep, that will be great. Okay. If you already logging into your account, please log in. Then RoboFlow will ask you to create a workspace. So the workspace is a space where you will put all your projects. You can create any project that you want to be able to detect an object. In this case, you can name your workspace with a specific name that you want to name it. And then you will choose the public plant, that is the free version of RoboFlow. Okay. Yeah, when you finish to name your workspace and choose the public plant, it will ask you to invite teammates. This is the part that you can add potentially labelers that can help you to label your data set. Also, you can integrate different users so they can explore your own project. And you can add them by their email address. But if you don't want to add anyone, we can move to the next step. Okay. Everyone is in this phase right now? Yep. Okay. Then you have to click into projects. Okay. Then you will select new project. It means that it will create a new project that to be able to detect a specific object. Then RoboFlow will ask you to name your project. You can put a specific name. The annotation group is the label that we will put to the object of detection. In this case, you can put dandelion, or you can put a specific name that you want. In this case will be, for example, if you are using the Coccinelle dataset, it will be an insect, or you can select dandelion. We will use the standard license. Also, other thing that you should know, we are creating a public space right now, so all the data set will be open source at the moment. So if you want to do your own research, you need to think about those things. Also, RoboFlow helps you to create different models. Not only it will help you to detect a specific object, but also it will help you to classify, also do some instance segmentation, keypod detection, and also construct different models within that can be classification or detection. For the purpose of this workshop, we will choose object detection, and then you have to create a public project that is in the bottom beneath a RoboFlow. Okay? Okay, we are good. Everyone is in this step? Okay, great. Then you will select the button that said select folder, and then you will choose the folder where you save the images. You can choose the 50 images of coccinellis, or you can choose the 50 images of dandelions. Okay. And then RoboFlow will start reading your imagery, and it will display it in the dashboard of RoboFlow. Okay. Then you will hit save and continue. And then it will display this screen that tells you how do you want to label your images. You have 3 options, but for the purpose of this workshop, we will learn how to label those. If you have, for example, a data set that has a lot of images, you can click on auto label, and it will help you with different models to to detect or to label your imagery. But the thing is that you need to pre-train a model so the model can detect the objects that you want to label. Also, you can pay RoboFlow to help you labeling your images if you want. But in this case, for the workshop, we will select manual labeling. You don't see that option? Yeah, you need to hit save and continue. No. Yeah, save and continue in the bottom part, and then it will display the 3 options of labeling. Then after you select manual labeling, it will show you your username. In this case, we will assign all the 50 images to ourselves to be able to label those imagery. So you have to hit the button that is beneath that says assign to myself, and then RoboFlow will assign you the 50 images. If you have, if you added before in that email that in the previous screen where it says invite teammates, they will also show in this display, and then you can split the data set. Like you can split the 50 images between your work team or anything. Then you have to click on assign to myself, and then you will see all the 50 images in your display, and then you have to click start annotating. Okay, we're good in this step. Yeah. Okay, after you hit start annotating, you have to select your first image that will be in the dashboard, so you can start labeling that image. It will display the image if you have a coccinellid or a dandelion, but the most important thing that I want you to explain you is the tool of labeling. The first option will help you to move your image in any position that you want. It's called the drag tool. The second option is called bounding box. Usually in a detection model, the inference will predict a bounding box where is the beetle located. The third option is a segmentation tool. It creates polygons in different objects. And also you have some AI labeling that will help you to automate the process of labeling. For the purpose of this workshop, we will use the bounding box. Right now I will show you a a video on how you will start labeling your images. You will select the bounding box tool, and then you have to label each individual coccinellid, and then you will click enter. That is the object of the name, and then you have to label all the 50 images to be able to train a detection model with 50 images. Also, we have a price to the one that labeled the 50 image first, so you can compete. And try to make the bounding box pretty near to the real object, so reduce any background. That will help to perform better the metrics of performance.
Any problems with this step? Are we able to make little buttons?
Also, if you choose the data set of the dandelions, it's not necessary that you need to label all the dandelions. Just select just one or two. It's just more to give you experience how to use the labeling platform. But when you want to do your research project, it's better to label. Labeling is a very important step in machine learning. Yep. Yeah, you can square one or two. It's not necessary that in that data set you need to label all of them, because maybe the model will be able to detect those when you finish training. Yeah, it depends how the dandelion is in the image. Some cases, the dandelion can have different rotations or something, and the model will not be able to predict. So my suggestion is to try to get a very accurate labeling, so also the model learns that type of rotation of the dandelion when you train. Right now, it's more for practice labeling to get you started in machine learning. Yeah. It depends on that. I receive that question every time, but I believe that it depends of your research question, what you want to do with the data. In my experience, at least in my research, we need at least 500 images to 1,000 images to be able to detect a small insect or a small pest in crops. Yep. Beetles or yeah, it will be detecting it individual object. Yeah. So if, for example, if you have an image that has 10 lady beetles and you wrote or you draw 10 bounding boxes, the model will predict 10 bounding boxes. Yep. 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 All right. You finish? Okay. We have a winner, so. Cool. Yeah, just let's give some time to the other ones to finish and then we can go to the next step. Okay. We are getting close. Yep. Yep. Yep.
The other one takes a little longer.
Work on in time, I think. Two minutes. Okay. Yep.
All right, so we'll give everybody another 3 minutes to finish up, and then we'll move to the second show.
Yep.
Doesn't matter if not fully or
Yeah, it's more give you hands-on experience of labeling because it can take time. Yep. Yes. Yes, it's possible. There is an option there that you can just delete it, the bounding box, select the bounding box, and then click in your keyboard, delete, and then it will work. Okay, so if you didn't finish, don't worry. We will already you labeled some of the images that will help to train the detection model. The next step is to go and add all your data set. Yep, that is the button is on your top right. You find that button or? Okay, I will go to you already click on that button, add to your images annotated, right? Then it will display, this is a very important part. Yep. Click in the button that is in the top that said add. Okay. Okay. Yeah, submit for review, and then it will display the ad. Okay, it work? Okay. After you hit that button, it will display this split. This is when you split the data set, so your model will have a set for training, a set for validation, and a set for testing. There is not a magic number. It depends of the research objective, but we can use the standard use that describe RoboFlow. That is the 17% of your 50 images will go to train the detection model. The 20% will go to validation, and the 10% will go to testing. You can also manipulate those numbers, and it's pretty good when you manipulate those numbers because you will have different performance or metrics about your computer vision model. Then after you select the split of 70, 20, and 10, you hit Add Images. That is in the bottom part of your screen. And then it will display this interface that says you have a top button in your top of your screen that says Train a Model. Okay. Click on Train a Model. Okay. Yep. I think that is based on the research question that you want to ask. You can do some testing. Usually, in my experience, if you want to create a classification model, for example, we use 80 and 20%, 80% for training and 20% for testing. In object detection models, we use 80, 10, and 10. It depends how much variability has your data set and what you want to detect. There is not a specific number. Yeah. Yeah. Yep. Any issues? Okay. So we are here, right? Most of you. Okay. You hit on Train a Model, and then it will ask you what you want to do. Okay. And you will select Custom Training. I didn't know the other option is I believe that RoboFlow just train immediately, but we will go to Custom Training. Okay. Then it will display information that you will have in the first line, your source of images. You should have there the number of images that you already labeled. It will tell you how many classes. You should have just one class depending of the name of the object. Then the second section will tell you how much your data set is splitting if you select 70, 20, or 10. Then the third step is about pre-processing. We will use the standard autorient that give RoboFlow. Also, you can add a pre-processing step. You can, in here, you can reduce the image size. You can increase the size of the image. You can put some techniques of image analysis there. But for this workshop, you just need to resize the image to 416 by 416, so the model can be training faster, because the real image, I think that is more than 3,000 by 4,000 pixels. Yep. Well, it will be the 70% of the 50. I don't know exactly the number. 35? Okay. Also, don't have to be perfect for the purpose of the workshop. But you can move those numbers around whenever you prefer. Okay? Everyone is in this step at the moment.
Okay, so the size of the images needs to be 640 by 640
Yeah, you can reduce the size of the image right now to 416 by 416. So the model will train faster. Yep. Reduce the pixel dimension of the image. Well, just reduce the size of the image. It doesn't do anything with the bounding box. It's just the pixel dimension. So the model can be training faster. If not, it will take longer. Because I think no, it just reduces the dimension of the image. It doesn't touch anything. It's not cropping. It's just reducing the dimension of the image. Okay? Huh? Mm-hmm. Yeah. Yeah, and also I will go, when we finish training, I will go through the limitations of RoboFlow. It's a good tool, but it cannot give you all the capabilities to create a detection model with different features and everything, but it's a good place to start. Oh. Yep. Mm-hmm. Yep, absolutely. Yeah, yeah. Also, you have other labeling tools. For example, for diseases, it could be better, instead of bounding boxes, it could be segmentation. So you can run the polygon tool, so you can select where is the area of the disease. We are good? Changing the, okay. So you will hit continue here, and then you hit create. Hit the button create. Then RoboFlow will start doing thinking or uploading something, but it will display this screen, and you will select custom train. Also, RoboFlow, you can upload a previous detection model so it can predict in the new data set. I never use that at the moment, but right now we will use custom train. And also RoboFlow give you some different open source models. In this case, we will use YOLO V11. Or you can choose any model that you want to try. Then you will hit continue. And we will select a fast training. If not, it will take forever to train this imagery. And then you will hit continue. And then you will select the second option, that is the recommended from RoboFlow. The model will be pre-trained before, so it's better to have a model that already learned something instead of having a model that doesn't have any background information. And then you will hit start training. And then RoboFlow will start packaging all your imagery, all your labels, and then it will send to the cloud base or to the computer infrastructure in RoboFlow. And then the process will start training. And also you can see the display charts about how is your model training depending on the time. And when training is finished, RoboFlow will send you an email and it will tell you your train is done. Okay, we are good in that step. Everyone is training the model right now? Yep, cool. Okay, so during the training, I want to show you how it works, machine learning, so you can have an overall understanding. Machine learning in practice is just describing or imagery features a computer can understand based on building a learning algorithm. Right now we build an algorithm inside RoboFlow, but there is another options that you can build your own code. In general, how it works as an overall machine learning, we are already creating a data set that has been labeled with RoboFlow. Then the model, depending on the model that you choose, the model will start scanning through the imagery and create a class probability map. So it will be sending different bounding boxes to be able to learn the features of the coccinellid in this case, or the dandelion. So the model will be able to produce these bounding boxes that you can see in here. And the main goal of building a detection model is not only to have the model, but having a robust model that can predict on images that the model didn't see it before. For example, in this case, as you can see, it's learning features from our training data set, and the model is also detecting in a new image. That is the main goal. And these can be applied to different research questions about disease detection, weed detection, insect detection, pest detection, or anything that can involve counting, so you can help speed up the process of counting tasks. Then, for example, this is a slide that Thanos suggested for this workshop, but I think that he's occupied there, but I will go through this. Overall, this YOLO, I believe that it started, I don't remember when, but right now we have like 12 different YOLO B models. When I started graduate school, we just have YOLO B5. So it's really speeded up the process really very fast. So the first version of YOLO, you have your image, right? Then the model will start to create a class probability map, and then the model will start sending different bounding boxes depending of your ground truth to trying to match that bounding box that you already labeled as a ground truth. Then the model will go through different layers, and it's explaining in this slide, and then it will send you the bounding box, okay? Then when you finish training the model and you upload the same image or a different image, it will send you a bounding box where potentially the object is detected. After you finish training, RoboFlow will send you an email and will tell you these 3 metrics. You can also use other metrics that you can calculate in the same code, but usually YOLO B models are evaluated with these metrics, that is precision, recall, and the mean average precision through a specific threshold. Precision is the fraction of detected objects that are actually present in the image. Recall measure how many of the actual objects in the image were successfully detected by the model, and the mean average precision is just a score that uses the ground truth bounding box and compare with the inferred detecting bounding box. If you want to understand better, you will have the presentation. There are some links in there that you can follow, and it can explain better these concepts. You can also use different other metrics like F1 score. Also, you can use a confusion metrics that we don't have the time to explain, but that is very useful to detect which is the best model. If you ask me which type of numbers we look to detect the best model, it depends of your project. In my case, that is more related with precision pest management. A model that is able to detect a pest that is more than 80% is a very robust model that can be built into a ground robotic vehicle that can detect that pest and make a management decision on it. In this slide, I want to explain you what are the limitations. Okay, what are the limitations of RoboFlow? One of the limitations, I received a question, image size. You cannot put any dimensional image. It has a specific pixel dimensions that RoboFlow will be able to learn to upload your data set. So that is a limitation. Also, you cannot fine-tune hyperparameters in the model, like changing batch size, epoch, or the learning rate. That is a limitation, but it's a very good tool for starting. Also, you don't have access to the code. That is a big limitation, so you cannot change the code or anything. But it's a very good tool to labeling images. It's very interactive. You can collaborate with your teammates and everything. Also, in the free version, it don't provide you detailed statistics about what is going on in the model, so it's pretty basic. But if you want to upgrade to a better account, you can do it. It has better interface to be able to detect the statistics. But if you want to get pretty into machine learning, build your own detection model, there are different open source platforms that you can use. Like Jupyter Notebooks with the Anaconda libraries that can help you build Python code. And then you can train your model with Google Colab. If you don't have a nice GPU or it's too expensive, Google Colab is a very good platform that you can send your model and it will be trained for you. And then, because we have 5 minutes, right, Thanos? Okay. So let me, okay. So if you want to see the results of your model, there is a button there that you can stop the training, I believe. Let me see. What is? Yeah. Yeah, you can stop the training of your model because we don't have a lot of time. So you can see the results. Everyone will have different results because I don't know how many images you label or how you label the images. But for example, when I trained this model before, and I don't remember if I used the 50 images that you have, but we have a very good results. And the reason that we have very good results, because the imagery that we collected is pretty clear, it's pretty in the object. So one of the suggestions that I have when you start doing machine learning, the code part is easy to implement right now. There is a lot of code sources that you can use and implement in your research. But the most important part is how you gather the imagery. That is really important. If you have an imagery that you visually cannot observe anything, your model will not be able to detect anything, okay? And the other second important part is the labeling. Labeling is really important when you want to build an object detection model. So for example, in this case, I was focused to be able to detect the coccinelle to literally visually observe, and the same cases with the dandelions. And we use different sensors, like RGB are really affordable right now. For this lady beetle, we use different cell phones that have very good camera resolutions. And for collecting these dandelions, we use these GoPro cameras, the cheap ones, to collect this data set and is able to infer. Also, when you finish training, RoboFlow also give you different options so you can deploy your model. For example, you can go to select a sample web app. When you select that, you can test your detection model, and I will show you this in the video. So you can browse an image that has a lady beetle on wheat, and then you run the inference, and then the model is able to locate the lady beetle and tell you how many they are, for example. Also, you can deploy this model into these 8 devices, NVIDIA Jetson or a Raspberry Pi. That is very helpful to deploy. Also, you can build your own web app, like for example, identified and a specific insect. Okay? And with that, thank you very much. Okay.